Okay, this is the study guide for statistics. We are just going to get started. I'm going to work through every single problem. So for number one, you have a group of friends compared the number of books they read over the summer holidays. The table shows the number of books read per person. We need to find the 5-number summary and the IQR. So I'm going to go ahead and put these into my graphing calculator. So stat edit, clear this out. I've said this before, I'll say it again, they don't need to be in order. We just want to put them in the calculator as is. I have turned off my stat plot, so I'm going to go ahead and turn it on. And then zoom 9 trace. You can see I have something else graphed in here. It's not necessary, doesn't matter. So now I'm going to go ahead. My median is 7. Q3 is 8. Maximum is 11. Q1 is 3. Oh, hold up. Okay, sorry about that, guys. So my minimum is 1. So I have 1, 3, 7, 8, 11. And then IQR, the interquartile range, is Q3 minus Q1, so that's a 5. Number 2 says, based on the data from the previous question, determine if the data has any outliers, and if so, what are they? So I'm going to show you 2 different ways that we can do this. First way is to take our IQR, which is 5, multiply that by 1.5. which gives me 7.5, and that's going to be my outlier value. Our upper fence is Q3 plus the outlier value, so that's going to be 15.5, and I can tell that I don't have any values above 15.5. For my lower fence, it's Q1 minus the outlier value, which is going to give me a negative value. So even without knowing that this is negative 4.5, I already know that there are no outliers, because that would be negative. Okay, another way that you can do this, and this is something I don't think I've shown you this before. If you press second y equals and select your first stat plot, it should be on, it should be set to this type. And if you go down and go over to this box and whisker plot right next to it with the 2 points, this will give you a box and whisker plot with outliers graphed if there are any. So if I select that and then press zoom 9, you can see that the box and whisker plot looks exactly the same as it did, and that's because this data value does not have any outliers. So that's just one quick way that you can check. I will tell you that if you graph a box and whisker plot with outliers, your box and whisker plot may not give you the correct 5-number summary. It's only useful to us right now to check to see if there are outliers. So like on your test, that might be a quick way to check. But you also should know how to calculate it using your outlier value, which is IQR times 1.5, adding it to Q3, subtracting it from Q1. Okay, let's move on to question number 3. It says, considering the following data set, calculate the mean and standard deviation. So I'm just going to go ahead and put that into my calculator. And then to find mean and standard deviation, I hit stat calc 1, and I get my 1 variable statistics. So for this data set, first thing, x bar, so we'll write the mean is this x bar, and it is 10. Standard deviation is this ponytail x, that Greek letter, and we want to, let's round to the nearest 100th, so it would be 2.20. So mean standard deviation is stat calc 1. Okay, question number 4. A sample of wait times in minutes to be seated at 2 popular restaurants is shown. The box and whisker plots compare the data. Describe the distribution of each data set. So for the first one, I remember on a box and whisker plot, we want to look at the distance between the two of these. These are pretty similar. They're close enough that makes me want to say that A is going to be pretty symmetric. Whereas you can tell for restaurant B, one side is significantly longer than the other, which means that B is going to be skewed. And the skew distance is the longer half, so B is going to be skewed to the right. Then if we're talking about measure of center, since A is symmetric, that means that for data set A, the mean would be a better measure of center, whereas B being skewed means the median would be a better measure of center. And the difference here is because data set A is symmetric, we use the mean, and because data set B is skewed, we use the median. Now, if we were wanting to compare these two, we would probably use the median to actually compare them because one of the data sets is skewed. Okay, 4 is continued on the next page. So C wants to know, is the interquartile range or standard deviation the better measure of spread? So for A, since it is symmetric, mean goes with standard deviation, and that's because it's symmetric. B is skewed, so that is interquartile range. And again, if we were wanting to use one of these measures to compare the two data sets, we would pick IQR because at least one of my values or one of my data sets is skewed. D, if you wanted to be seated more quickly, which restaurant would you choose, and justify your reasoning using the data. Personally, you would have to decide whether or not you want to take a chance. Restaurant B has a lot smaller values, but you also run the chance of it taking an hour for you to get done. I might pick A because their wait times are more consistent. So I have a much better idea of how long it's going to take. Most people would say restaurant B because they have so many values that are low that the chances of them getting seated quickly are higher. Okay. Number 5, the box and whisker plot represents the number of students in classrooms at a school. What percent of classrooms have 23 or more students? So 23 is here, that represents this part, 23 or more. This whisker represents 25%. Remember that each section represents 25%. For part B, what percent of classrooms have between 17 to 23 students? So 17 is here to 23. That's going to be my box. We know that each section is 25, so the whole box represents 50% of the data. Number 6, the manager of a bakery wants to compare the sales records of 2 types of cake. The table shows the number of each type sold per week for 11 weeks. We want to calculate the 5-number summary and IQR for each type. So, for velvet, wrote out my numbers, and now I'm going to put them into my calculator so that we can see where we're at. I'm going to make sure really quick that I change this back to the regular type of box and whisker plot, just to make sure that my values come out correctly. So we're going to start here. My minimum is 3. My Q1 is 5. Median is 9. Q3 is 13. And maximum is 15. So then my IQR is going to be 13 minus 5, which is 8. Now I'm going to do the same thing for my swirl cakes. So my minimum is 1, Q1 is 5, median is 9, Q3 is 11, max is 22. My IQR 11 minus 5 gives me 6. Now it says identify any outliers for each type of cake. I'm going to show you the graphing method again. You could identify your upper and lower fences for each of these problems, but I'm going to tell you, if this is on the test, I would recommend that you use the graphing method on your calculator just because it's faster. So I already have the swirl cakes in my graphing calculator. So I'm going to press second y equals, and I'm going to change my plot to the outlier version, and I'm going to press zoom 9. And you can see here that there is one outlier up here. If I press trace and I go over, it'll tell me what it is. So 22 is in fact an outlier. So swirl has 22. I'm going to go back really quick and graph this for you so that you can see. Here is the box and whisker plot for the velvet cakes. You can tell that there are no outliers because I am on that type, and if you're not sure, you can just double check here. So since I'm on the outlier type and there are none, that means there are no outliers. So I'm going to write that. There are a couple of questions on the test that ask you to identify outliers for a data set. So this method will be helpful. However, there are also questions on the test that ask you what the upper fence of the data is or what the lower fence is. So you will need to know how to calculate that just so that you are prepared. Okay, last question. Number 7, describe the distribution of each data set. So if I do that and then I do this. Data set A is very spread out, but you can see how it's high on either end, and there are some things in the middle. I would actually tell you that data set A is relatively symmetric. Even though the highest point is not right in the middle, it is about the same on both sides. Maybe a little bit skewed to the right, barely. Data set B is quite obviously skewed, and the lower side is on the right, so that is definitely skewed to the right. Now it says predict which of the data sets has a higher standard deviation and explain your reasoning. Okay, so between these two data sets, we talked about how the middle is right about here, and there are a lot of values to the left of that and a lot of values to the right of that. Whereas in data set B, if we're going to talk, standard deviation goes with the mean or the average, and your average is probably going to be about here. There are a lot of values to one side of your average, but not a lot to the other side of the average. And so, because A has a lot of points on either side, that means that data set A is going to have a higher standard deviation. And the reason is because most values are far from the estimated mean. And again, it's because your mean or your average is going to be somewhere pretty close to the very middle of this, but majority of the points are on the ends, the furthest away, rather than very, very, very close. If the majority of your data was really, really close to the center here, then that would have a very low standard deviation. And then again for B, your average is going to be probably, I'd guess, right around 29. And you have a lot of points to the left, but not very many points to the right. Actually, it might even be closer to 27 or 28. And so the mean is a lot closer to the cluster of values here, whereas the mean is far from the clusters in data set A.